So the last part of this chapter is talking about volume. We'll spend today and tomorrow looking at volume. We're also going to go through the chapter 1 quiz today. And that means on Monday you guys will have your quiz on chapter 2, which deals with surface area and volume. So we did see one question involving volume, I think on our first day of chapter 2. Volume is what fits inside of an object. It has to be a three-dimensional object. And the formulas for volume are on your formula sheet, so you don't have to memorize them. This first one is a rectangular prism or a box, and the formula for volume says on your formula sheet, capital B times H, where B is the area of the base. The base is a rectangle. The area of a rectangle is length times width, and then you're going to multiply by the height of the prism. So the volume of a box is simply length times width times height. So if we say that 20 is the length, 9 is the width, and 8 is the height, we just multiply those three together. So it actually doesn't matter in this case what you say L and W is. You could switch those two around. You're just going to multiply these three numbers together, and when you're multiplying, order doesn't matter. So 20 centimeters times 9 centimeters times 8 centimeters. We multiply those three together, and we'll have the volume. Which is 1440. And because you're multiplying centimeters by centimeters by centimeters, that'll be centimeters cubed. Keen. Get on the right page and get this stuff copied down. Okay, so what this means is if you had small cubes that measure 1 centimeter by 1 centimeter by 1 centimeter, it would take 1440 of them to fill up that box completely, because that's what volume measures. We want to determine the volume of these shapes. Again, the first one is a box, and the volume of a box is length times width times height. Each of them is 5 inches, so you can just write this as 5 inches all cubed. That means you're going to multiply it by itself 3 times, which would be 125 cubic inches. That's the volume of that box. Now the second one is a cylinder. And if you look on the formula sheet, the formula for volume of a cylinder is pi r squared h times height. It's the area of the base times the height. The base is a circle, and the area of a circle is pi r squared. So that cylinder has a radius of 4 centimeters and a height of 15 centimeters. Those are the values of R and H. But the formula tells us that you have to square the radius. And once again, we can put this entire thing in our calculator and do it in one step. Your calculator does order of operations. Pi times 4 squared times 15 is 753.98. And I'm going to round this one. So I'll use approximately equal to. And once again, volume is in units cubed. So that'll be 753.98 cubic centimeters. And once again, what that means is if you had small boxes measuring 1 centimeter by 1 centimeter by 1 centimeter, that's how many it would take to fill it up completely. Okay? So on to the next one. It says match each 3D object with its volume formula. Again, these are on the formula sheet. Okay? And the first one is a pyramid. And if you look On the formula sheet, it says the volume of the pyramid is 1/3 capital B times H, where again, B is the area of the base. So it would be 1/3 length times width times height, which is the last formula. The middle shape is a cone, and if you look on the formula sheet, it tells you what the volume of a cone is. It's 1/3 pi r squared h. And the last shape is a sphere, a ball. And again, the formula sheet tells you that the formula for volume of a sphere is 4/3 pi r cubed. So you don't have to memorize these formulas. You'll be given this same formula sheet for your quiz on Monday, as well as your future quizzes and tests. So this next one asks us to find the volume of the right cylinder. Again, the right part just means that the base is perpendicular to the side, which all of ours will be. We want to first find the volume of the right cylinder, then the volume of the cone that's inside that cylinder. But first we start with the cylinder. And according to the formula sheet, the volume of a cylinder again is pi r squared h. In this case, you're given the diameter to be 5 centimeters. The radius would be half of that, 2.5 centimeters, and that needs to be squared, times the height, which is 12 centimeters. So we've got pi times 2.5 squared times 12. So to the nearest tenth, that'd be 235.6. And again, volume is always in units cubed. Now, part B wants the volume of the cone. The only difference between volume of a cone and cylinder is that the cone is 1/3 pi r squared h. Or in this case, 1/3 of 235.6. So again, we rounded that number down to write it, but we've got the entire value in our calculator, so you can multiply that by 1/3, which is the same as dividing by 3. So I just took the previous number and divided by 3, and again to the nearest tenth it would be 78.5 centimeters cubed. All right, so for the your turn at the bottom, again we want to find first the volume of the cylinder. Formula is pi r squared h. In this case, you're given the radius, not the diameter. R would be 10, and h, the height, is 22. And this one we want to do to the nearest cubic centimeter. So it's pi times 10 squared times 22. Squared times 22. So to the nearest cubic centimeter, it would be 6912. And the cone, once again, with the same base and the same height, the formula for cone is 1/3 pi r squared h, or 1/3 of the number we just got. Again, when I wrote it down, I rounded it, but we have the number in our calculator, so we can just multiply that by 1/3, which is the same as dividing by 3. So to the nearest cubic centimeter, it would be 2304 centimeters cubed. So again, you're given all the formulas, you just got to use them. Many of the operating costs of a greenhouse depend on its volume. For example, the energy used to heat a building depends on the volume of the building. Two large greenhouses at the Mutart Conservatory, that's in Edmonton, down in the river valley. You can go see them. They are greenhouses. You can walk in. They have square bases measuring 26 meters on each side, and the apex, which is the height, is 24 meters. What is the volume to the nearest cubic meter? So again, this is a pyramid. And if you look on the formula sheet, the volume of a pyramid is, again, 1/3 the volume of a box with the same base and height. It's 1/3. Now again, the formula sheet says 1/3 capital B times H, where capital B is the base. That's length times width times H, the height. So in this case, the base is a square measuring 26 meters on each side. So that's our length and our width. And the apex is 24 meters high. That's our height. So you can do this if you want by going 1 divided by 3 in brackets times 26 times another 26 times a 24. And there's your answer, 5408 cubic meters. You also could have done this. We've said before that multiplying by 1/3 is the same as dividing by 3. If you go 26 times 26 times 24 and then divide by 3 instead of multiplying by 1/3, you get exactly the same answer. We've talked about that before. So there's the volume of each of those greenhouses. But there are also two smaller greenhouses. The base of each greenhouse is a square and the side lengths are 19.5 meters and a height of 18 meters. What is the volume of the smaller greenhouse? So again, the volume of a pyramid is 1/3 length times width times height. 1/3. The base is a square that measures 19.5 meters. That's the length and the width. And the height of it is 18 meters. And like we've seen or said before, multiplying by 1/3 is the same as dividing by 3. So in this case, I'll take the 19.5, and instead of multiplying by another 19.5, I can just square it. That means 19.5 times 19.5. That's multiplied by 18, and then we need to divide by 3. So there's the volume of the smaller greenhouse, 2281.5. And again, remember, volume is always in units cubed. If the smaller greenhouse had been designed as a right rectangular prism, in other words, a box instead of a pyramid, with the same size base, what would its height have to be in order to have the same volume? So the volume of a box is length times width times height. We want the volume to be the same, 2281.5. And again, it says that the base has the same size, so that's 19.5 meters by 19.5 meters. We want to find out what h the height would need to be so that the volume was the same. So on the right, you've got 19.5 times itself, or squared. That part alone is 380.25. So 2281 meters cubed will equal 380.25. And on this side, it's meters squared because you multiplied meters times h. To get h by itself, then we would divide both sides by the 380.25 meters squared. Change colors here. 380.25 meters squared. So on the right side, the 380.25 meters squared will cancel. You'll have h by itself. And on the left side, we need to take that 2281.5 and divide it by that previous answer. So the height would have to be 6 meters. You're also dividing meters cubed by meters squared. And for that, we follow our laws of exponents. You're dividing powers with the same base, so you subtract the exponents and the base stays the same. I forgot the 0.5 when I wrote this down. There we go. Okay? So we're going to stop there for the lesson. We'll finish this off tomorrow. So what you can work on for practice, and again, I would strongly recommend that you do the practice. It's going to help you for your quiz, which will be on Monday, on page 86 to 89, questions 2, 3, 5 through 7, 10, 12, and 14. You should work on those for practice. It'll help you for your quiz again. We're not done yet. Just have a seat. Pretty quick. Okay, everyone got that copy down?